What's up, everybody? Welcome to the third full episode of the Scala Logs. I hope you and your families are all doing well in these times. We have Michael Pilquist with us today to talk about streaming with FS2. Be sure to check out FS2 after the podcast if you like what you hear. We'll jump right into the interview. So how did FS2 begin? Like, what was the kind of the beginning of it?
It started with functional programming in Scala, Runar and Paul's book. I think it was chapter 11 of that book, maybe. And out of that grew a library called Scala's eStream. And that, was pretty popular for a while. I started working with it probably around like the 0.6 release of Scala's eStream, somewhere in like 2013 or so. Pretty quickly started getting help from Paul, and eventually ended up joining the team of maintainers and really focused on like API design and sort of like ergonomics of the library. And then over time, we gradually renamed it. When we removed the Scala's E dependency, we decided it was kind of silly to continue to call it Scala's eStream. In the 0.9 release, founded functional streams for Scala.
As someone coming like brand new into streaming, like what problems does FS2 solve that these other libraries don't?
Yeah, there's a couple different ways to look at that. One is that FS2 provides a really powerful set of APIs for building infinite collections in a sense. So if you sort of imagine like the standard libraries built-in stream type or the lazy list type, but kind of supercharge the capabilities of it, FS2 as a starting point, provides a really nice alternative to those. But then it certainly layers in a ton of additional functionality. So the biggest is working with effect types. So if you have programs written in the IO data type, or Monix's task, and you want to sort of interleave those effect evaluations with this notion of like infinite streaming or processing data that's too big to fit into memory at any given time, FS2 directly provides support for doing that. And then finally, FS2 has a bunch of sort of interesting ways to represent programs as streams of data or as streams of control. And so sort of a little bit different than like imagining data that can't fit into memory, but rather you can use streams, FS2 streams, to like organize your program, different parts of your programs, and sort of compose all those different parts together, to build those bigger systems.
Yeah. So when working with FS2, then it seems like there are a couple building blocks. Like, so stream is maybe the main one?
That's right.
Can you kind of go into how, like, what that provides the user?
Yeah. So the stream data type, maybe unlike some other streaming libraries, is parameterized by two types. So the second one is sort of the one everybody's used to, right? Like when we think of working with a list, we want a list of integers or a list of bytes or something like that. So certainly stream would let us talk about the output type that our stream can produce. But stream is also parameterized by the effect type, the types of effects that can be evaluated. So it's often, when you first get started with FS2, you'll have to decide, like, do we want to work with a stream of IO comma byte? A stream that can potentially evaluate effects in the IO monad, producing chunks of bytes. And that chunk terminology, we'll probably come back to. But the general idea here is that when working with FS2 streams, internally, we're going to represent our output types with a set of like densely packed, in-memory storage of our individual output elements. So there's a key data type as well called chunk. It has all sorts of different constructors. It can wrap, native arrays. It can wrap, Java NIO byte buffers. Has integration with Scodec for wrapping bit vectors and byte vectors there. But anyway, so you can sort of think of stream as this engine, if you will, or this high-level language that lets you talk about how I acquire these chunks of my output elements, perhaps through effect evaluation, and then how to manipulate them, transform them, and eventually compile them down to a program that can be run.
We can kind of go into chunks then. Are chunks, in a way to group internally, or does the user actually have to deal with chunking as well?
Yeah. So from an API perspective, you have an option. So normally you would not worry about chunks too much. A lot of the built-in libraries that get built on top of the FS2 primitives do their best to acquire data in a chunky fashion. So a great example is working with byte arrays. Certainly if we read tons and tons of gigabytes worth of data from disk or from the network or something, we wouldn't want to individually box each byte on the heap, right? And so the connectors, if you will, like the sources that you work with, often will read data in terms of these chunks and push them through the FS2 internals in their densely packed, maybe array-backed structures. So the FS2 API sort of lets you ignore all of that, and you can still think about working with the individual elements, and all the built-in combinators then sort of really get implemented by implementing their logic on top of these densely packed chunks. But if at any given point you do need to dive down into chunks and really start thinking about the performance, there are ways to do that. So you can sort of expose the chunk structure. That's one of the things we talk about a lot when talking about writing performant combinators, and then sort of operate on the chunk structure and then push it back down into the details of your stream.
It's not something that someone brand new at least would have to fully be dealing with. Right.
Yeah. I mean, normally, you're going to use maybe the FS2 IO project if you're working with sockets or file access. Or if you're working with Kafka, you're going to use FS2 Kafka. There's tons of integrations, and really when you're writing your own sources, that's when you really want to think about that. But if you're just getting started, you don't necessarily have to run into chunks right away.
So the next one that's kind of in the guide is poll, which I personally at least found to be the most confusing or more difficult one to wrap my head around as to what the use case exactly are.
Yeah, the pool data type really is the heart of FS2. So stream is what we think about, right? When we think of a streaming library, that I can evaluate some effects and I can output some values. But really, the stream data type in FS2 is just like a thin API wrapper on top of this concept called a pull. From the name, you can probably guess FS2 is a pull-based streaming API, not a push-based API like, let's say, Monix's observable. So pull is like stream, but we add an extra type parameter. So typically when we look at pull, we'll talk about a pull has a type parameter F, which is our effect that we can evaluate. It has an output type O, just like streams. But then it has a result type R. And this is what sometimes takes some getting used to when learning the library. The idea behind a pull is that when we eventually evaluate it, when we eventually turn it into a program and go and execute that program, it can evaluate effects of that type F, and it can emit or output elements of that type O or chunks of that element. But eventually, when it's done all of its work, it's going to complete with a single value of type R. It has a result value R. So that sort of seems strange, right? Because stream doesn't really complete. A stream outputs elements and then it's either done, and just stops execution, or it can continue forever, right? Outputting elements. But pulls really have this discrete output type R, which is unrelated, result type R, which is unrelated to the output elements. What this enables, the idea behind this, is that we can really write recursive algorithms that structure our stream programs. So it's very common where you'd write a pull, which eventually completes in some value R, which then you can like flat map on that pull, access that R, and decide what to do next. So the pull type really forms a monad in the result type, as opposed to stream, which really forms a monad in the output type. And so sort of thinking about that and studying that difference sometimes can be illuminating. So for example, the stream monad is basically the same as like the list monad, right? It has the additional supercharged powers of FS2 streams, of course. But the idea being that, just like on list, for each element in the outputted stream, when you flat map, your function is going to be called, and you can compute a new stream. And just like, flat map on list, the result is sort of the result of concatenating all of those new streams together, right? Whereas pull, that result type monad, really says, hey, when this whole thing's done and it's outputting all of these elements and everything's finished, now it has some result R, and you can use that R to decide what to do next. That's sort of the key difference.
All right. Is that would pull be something that a lot of users would end up using, or is that mostly an internal?
Yeah. I think most users do end up using pull at some point. FS2 has a ton of built-in combinators. It's a very rich set of APIs built off of a relatively small set of internal primitives. Our primitive count changes over time as we optimize and adjust internals, but I think it's right now somewhere around like 18 or 14 core primitive internal concepts or operations or algebra elements, if you will. But the FS2 API builds a whole ton, hundreds of useful combinators on top of that. But if your particular use case isn't provided by one of the built-in combinators or, sequencing some of those built-in operations, then you might want to write your own recursive algorithm to decide, how to pull elements. And that's really where it comes in. We really wanted a functional API, a safe API to use to write those custom combinators, as opposed to like having to manipulate low-level internal details and like wiring things together and dealing with mutability, et cetera. We wanted all the power of functional programming, but still give users that flexibility to really do custom transformations of their stream graphs.
So you mentioned some of these like powerful combinators. Do you have any examples of ones that you think are like kind of show the power of FS2?
Yeah, there's a bunch. Maybe off the top of my head, I would say the concurrently operation. We have an operation called concurrently, which ends up being like the main way in which we get flow control out of FS2. So the idea behind concurrently is if you have two streams, one stream maybe that's processing elements from let's say a Kafka queue, and then updating some like in-memory representation of the data that's been processed. And you have like another stream that maybe is periodically reaching out to a system and doing health checks, and if an error has to occur or detects an error, it needs to go and fire off a message or something. If I have these two streams, like how do I compose them together to like represent my overall program? And so the concurrently operation really lets me to stitch them together and say, hey, my main program is going to be this Kafka, logic. But while that stream is evaluating, while it's pulling elements, I want you to, at the same time, go off and do this other stream and sort of, stitch together the effects over like a cat's effect provided, execution environment. So concurrently ends up being kind of interesting in that sense. That second stream doesn't ever sort of output elements in a meaningful way. There are ways to do that. Like we support merging streams. We support, parallel execution, then joining the results with full back pressure, et cetera. But concurrently, by taking away some of that power and saying, hey, that second stream we're running, we're not going to look at its output elements. We're just going to sort of run it while this other one's running. And then we're going to tie together the life cycles of those streams. Like if the main stream goes away, then the one running in the background should go away as well. If the mainstream errors out, then the one running in the background should terminate gracefully. That ends up being kind of an interesting one.
Yeah, so we're kind of talking about when the streams either halt or they error out. Can you talk about halting a little bit?
Sure. There's a lot of different ways that FS2 streams halt. The most obvious is that the source, wherever we're getting our data, is done. If I'm reading from a file, I've reached the end of the file. If I am working with like a collection or a finite set of elements in memory, I've just reached the end of that. I've pulled all those elements, right? So there's a natural termination. There's also early termination. Simplest way to understand this one is just imagine the take combinator. So if I have a stream of bytes, maybe representing a file on disk, and I say take 1,000, the resulting stream, when it reaches that 1,000th byte, is going to terminate early, right? So our source is still has plenty of data, but we're just going to stop reading from it. But that take operation needs to respect, all of the resource acquisition and lifecycle constraints that come into play there. So if I opened a file on disk and I only took 1,000 bytes from it, but that file has plenty more data, I have to make sure that that file is closed in a timely fashion, sort of when you'd expect, if you will, and make sure that as we use those 1,000 bytes later on in our program, we're not sort of artificially extending the life cycle of that open file handle in ways in which you wouldn't expect. So some of this sort of dovetails into like the cat's effect notion of bracketing, but also there's some stuff here with FS2 streams where resource life cycles while in streams can end up being a little bit different. So that was two ways, source termination, early termination. The third way streams halt is, via some type of error. So if an error does occur in the evaluation of a stream, then stream processing is terminated. Like there's no ability, like some other streaming libraries, to like resume. You can't say sort of ignore the error and continue to process. So anyway, when an error does occur, that error is reported through the overall effect type that you compile your stream to. If you compile your stream to IO, the error is reported as, sort of the equivalent of calling like raise error on that IO data type. If you're working with pure streams, where there is no effect, then it is not possible. The FS2 API doesn't make it or doesn't allow that stream to actually fail with an error.
Kind of looking to the future of FS2, is there any new features or changes that are coming up?
I would say the main API of FS2 we're pretty happy with right now. We have a lot of support for concurrency, broadcasting and round robining and balancing stream data across graphs of streams, etc. So API wise, I say we're in a really solid place. No major, planned refactorings. It's safe to build enterprise software on the current API. And in fact, I have done that for the past, something like 7 years. Really, I think the next major evolution of FS2 will be aligned with CATS Effect 3, excuse me. So with CATS Effect 3, we're looking at sort of changing around the type class hierarchy a bit. Notably, the concurrent type class will no longer extend the sync type class. And hence, we get better parametric reasoning when we look at operations. Right now, all the places in FS2 where we take a concurrent constraint, we're picking up this extra sync constraint. And hence, sometimes it can be a little hard to reason about like what the possible things are that this particular method could do. Really CATS Effect 3 is the main focus. And we expect the API itself, while it won't be source compatible or binary compatible due to the changes in CATS Effect 3, like the operations and the main ideas, streams and pulls and chunks, those will all be the same.
That's good. So kind of building off of FS2, you have a library called Scodec. Would you want to kind of talk about what that is?
Yeah. Scodec is a combinator-based library for working with binary data. There's really a few sub libraries. The first is Scodec bits. Scodec bits provides two immutable data types for working with effectively immutable byte arrays. So there's a byte vector type, sort of similar to like Akka's byte string, if you've worked with that. And then there's a bit vector type, which is the same. It's just a transformation, but it lets us sort of take individual bits from underlying byte arrays, manipulate them at the bit level, put them back, do bitwise operations, those types of things. So Scodec bits provides that as like a set of foundational data structures for the rest of the Scodec libraries. The real meat of Scodec is in the Scodec core project. Scodec core, really, its main data type is called codec, and it lets us encode and decode values in Scala to strings of bits. We wanted this to be a combinator-based library in the sense that I could have a codec for like an individual flag. Like imagine a codec of a Boolean that represents a single flag or a single bit in a binary representation, right? If it's 0, it's going to map to false, and if it's 1, it's going to map to true. So if I have this a codec of Boolean representing one bit, now maybe I put 13 of those codecs together. Like I repeat that codec 13 times, and I end up with a codec of 13 bits, or 13 Booleans. And really going from that focused of a level of like manipulating individual bits, I want to be able to continue to build up a codec larger and larger in order to represent like an entire, let's say, MPEG video file. And so really the codec type is all about how can I encode and decode such values without resorting to mutability, without losing referential transparency that we love from functional programming, but use it in industrial strength, applications where performance is important, etc. And notably, like this is not Scodec is not really about like pickling, right? Like just saying, hey, I've got a random Scala data type and I need to just get it to binary to store it to a database or something. Really, it's more focused on contract first, binary representations. Like, hey, I've got the MPEG spec. I've got 600 pages of all of these different, message formats, and I need to write code that's sort of obviously correct, right? When we look at the structure of our serialization code compared to the specification format. And the only other project in the Scodec suite I'd like to mention is the Scodec stream library, which is really integration between FS2 and that Scodec core project. You can imagine, like, if I've got a stream of bits coming from the network, and I've got a set of Scodec defined serializers, codecs to represent, how to convert individual bits into data structures. There's probably some interesting way we can kind of stitch those together and produce something that can do like streaming parsing of network messages. That's what the Scodec stream library provides.
If I was brand new to coming to Scodec, what packages would I gonna go look at right away? Like what was the main thing?
Yeah, I would say it depends on why why you're looking at Scodec. So there's two different places to start. If you have the need to process some type of binary representation and parse it, maybe it's like an IoT type project and you've got some protocol where you're trying to parse messages, then definitely Scodec core is where to start, and take a look at the codec type and the various examples built up from it. If instead, like you just need to work with binary, maybe reading stuff from disk or networks or whatever, and you want to kind of just manipulate it, but you need a data type that's performant, that has good like concatenation qualities, things like that. Then Scodec bits is where you want to start. That bit vector type and that byte vector type. What's interesting about those two places is that like the latter category, there'll be many, many, many more folks where that's going to be relevant. It's a little bit more rare to have to process binary, in a serialization type format with custom specifications.
Mm-hmm. If I was looking to get involved right now, so let's say I wanted to help maintain Scodec, what's the best way for me to do that?
Oh, I would love that. Yeah. Folks could certainly come to the Gitter chat room. We do have a pretty active chat, Scodec/Scodec. And then there's open issues on the issue tracker. Feel free to grab one or post a question saying like, hey, can anyone let me know how to proceed with this particular issue? We're always looking for additional contributors, maintainers, etc. And that's for FS2 as well. And same type of venues. Gitter chat is probably the primary venue, but certainly the issue tracker as a secondary source.
Is there any future pieces for Scodec right now, or is it pretty stable?
I'd say it's pretty stable. Scodec, I think Scodec was also 2013. It was released, and is used in tons and tons of projects. Scodec bits in particular has only ever had one binary incompatible release. And so like the API wise, I'd say they're all very stable. But we do continuously add new features. Someone just contributed like base 32 support to Scodec bits, which actually I don't think has made a release yet, but it will soon. There's always new features that we're interested in adding. The other thing I should point out is that Scodec bits right now is cross-building for Dotty, whereas Scodec core has moved. Our Scala 2 support is sort of finalized in a sense. And really we've ported the library to Dotty, to Scala 3, and removed like the dependency on shapeless and really focused on like how can we streamline this API using the new features in Scala 3. And so if you're interested in Scala 3 or some of those new features, there's some interesting work that's going on in Scodec core as a result of that.
Well, let's jump right into Dotty then. So what's exciting about it to you?
For me, it's really like a rejuvenation of features. It reminds me when I was first learning Scala and I felt like there's all these new ways we could sort of creatively express ourselves, at least coming from like a Java background. And after 10 years doing Scala, I felt like we had sort of knew what we had, right? Sort of knew all of the nooks and crannies of the language. And with Scala 3, there's not like, dozens of new features that are just overwhelming. Rather, there's a set of really, I find really smartly chosen simplifications that manifest sort of in powerful ways. If I use this new feature and that new feature in this way, I can really simplify my programs without all the complexity I had, using things like inductive type class derivations and, constraint-based solving, things like that. So in particular, one of my favorite features is the fact that tuples in Dotty are now inductive. Like I can write a function that says, given some arbitrary tuple of an arbitrary arity, like you could hand me a tuple 2, I could give you back a tuple 3. Or if you gave me a tuple 3, I can hand you back a tuple 4. And I don't have to write like a case, for each of the possible tuple sizes that could get passed to me, right? So I can write functions that are polymorphic in the arity of the tuple. For Scodec, that is a massively simplifying idea. Scodec did use shapeless. And if you think about like this notion of inductive tuples, it's basically a shapeless heterogeneous list. So Scodec used shapeless not in its internals, but in its public API. Like if in my example earlier, like if I had 13 codec of Boolean and I stitched them all together, I'd get back like a codec of an H list of 13 Booleans. Now that's just a codec of 13, right? A codec of a tuple of 13 Booleans. And so like, it seems like a pretty simple change. Like, it's just sort of renaming an H list into a tuple. but that idea sort of percolates through all of the combinators, through all of the API, and really sort of solidifies it all to just have so many less options and so much more consistency throughout the API set.
Yeah, that's really, really exciting. So kind of switching away from programming, more on a personal note, what do you enjoy doing with your free time?
Right now, I would say I am very, very interested in road cycling. Sort of got the bug a year ago, and at least when I can get outside and spend some time, learning my local area. But that's been a lot of fun.
Good. At least it's spring now.
Yeah. Yeah. I even did I got into the indoor trainers in the winter, but yeah, this time of year, it's finally nice enough to spend some time outside.
Mm-hmm. Can you talk about your first introduction to programming?
Sure. I started, depending on where you start counting, I guess, I would say I started with Basic A, and really like building sort of database type apps. Just kind of kicking the tires of Basic A, and then eventually GW Basic, and then Q Basic. Never had the funds for Quick Basic. But yeah, so definitely the Basic family was my introduction. I was always sort of intimidated as a kid with C and with other languages, but eventually moved on and spent a long time doing C, C++, and then eventually moved into the Java ecosystem, and at least as part of my professional career, started basically in Java and some time in .NET.
How did you end up starting in FP?
I think in university, I was very interested in ML, but I didn't put it into practice much. I mean, it was certainly a major interest there, and that turned into like a more academic interest into lambda calculus. Eventually worked a little bit on pi calculus with my advisor at the time. But once I got into industry, I sort of fell away from FP and just sort of went down the Java and .NET route. I think around 2008 or 9, just listening to the Java posse and listening primarily to Dick Wall talk about how much he was enjoying this new thing called Scala. That sort of piqued my interest, and ended up picking up Bill Venner's and Lex Spoon and Martin Odersky's Stairway Scala book, and got hooked pretty quickly. Really liked it at the time because I felt like in Java, a lot of the best practices for building concurrent data or concurrent systems with like immutable data structures and domain-driven designs and things like that. I felt like we were spending a lot of time sort of fighting against the ecosystem and the direction in which it was going. So if we're trying to build like these highly concurrent systems with all sorts of immutable structures, but then also trying to like use JPA and like entity models, it just sort of felt like we were being pulled in two different directions. And so Scala at the time was really a massively simplifying idea. Like let's sort of just go back to data and write functions on that data. And for concurrency, let's just use actors. And so at the time, standard library actors, this was before Akka existed. Standard library actors was like a huge draw. And really it was like the simplifying set of constructs for these concurrent, big concurrent state machine sort of base programs I was working on at the time.
Did you get started in Scala then because of industry?
I did, yeah. I would say pretty quickly it went from this interesting idea, this interesting language to like, hey, this can really solve problems that we were facing in industry. So I don't remember exactly how much time that took, but it went pretty quickly from like, this is an experiment to like, hey, let's write some unit tests in this new language. It's compatible with our current build system. To then, overall our entire team sort of switching and saying, this is a game changer for the way in which we can write concurrent programs that are more correct, that have less defects than the types of languages and libraries we were using at the time.
Yeah, I honestly feel like that's the pull for FS2 is the like there's the theory behind it. It's streaming. There's the resource safety, which is a big pull for industry. It should be at least. And then there's I can do awake every and start a program that starts up every 5 minutes and pulls something for myself and sticks it in a database and then writes the file out in about 5 lines.
Right.
Like that's a giant boost. That would take me forever in some other languages.
Yeah, and I think what's interesting is that in both cases, in Scodec and in FS2, like the key idea or the key enabling idea is composition, right? Is all about like I'm going to make tiny little programs in Stream or in Codec, and I can scale those tiny little programs all the way up to be like massive systems. And I'm still using the same data structures to do that. So I think that's a really interesting property of those types of libraries.
Yeah, definitely. It's a big pull. So kind of bouncing back to technologies and ideas, what have you been learning lately?
Well, Dottie really has taken the most of my attention on the technology fronts. Learning the macro system and learning like the compile time metaprogramming facilities there. Sort of outside of the Scala space or the software space, I kind of have a hobbyist interest in math in general. So going back and right now I'm reading Naive Set Theory, sort of a classic book on set theory. And then I have like a whole stack of books here and texts here that I've collected that I've been meaning to get to. So hopefully moving on to some abstract algebra pretty soon.
So other than math books, do you have any other favorite books?
Oh, other than math books, I'm going to ignore that and just say Dr. Eugenia Chang's books, in particular, How to Bake Pie. It is a math book, but it is not a math book. It's fantastic. Really interesting look at abstraction and in essence category theory. But it's a book you can read on the beach. It's not a text. It really is just amazing the way it can take sort of such complex ideas and put it in a form that's extremely accessible.
I think that was the first book I think I've read within the day I got it. And then I had to go reread it because I was like, this was really good, but I don't think I got everything I needed out of this. And like I came back and I was just like, I just read a math book in a day.
Yeah, she's fantastic. And she has quite a few others too that I also recommend. But that one in particular I would start with if anyone hasn't read it.
Are there any subjects or anything that like you think everyone should know or be using?
No, I don't think so. And I mean, I guess one thing I would say is often in the functional programming space, our interests in things like abstract algebra or category theory can seem intimidating to folks that are sort of looking at that and evaluating FP. And I would just encourage folks that like you really don't need to have an interest in those topics to be productive with FP. If you have zero interest whatsoever in learning category theory, that's totally cool, and you can be a library author or maintainer or whatever. You can certainly apply it. These things are really optional in a sense. They certainly help, but by no means are they necessary.
Yeah, definitely. Well, it was really great to have you on the podcast.
Thank you so much for having me. This was a lot of fun.
Thank you.